how this inverter works is it's basically taking solar energy, which trickles throughout the day. So it's higher at some times, lower at other times. Energy from the sun. That's captured in photovoltaics, and it's DC, so it's direct current like a battery, and then that's fed to this inverter, and the inverter turns it into AC, which is like what your house runs on, and so then it provides like a continuous power supply to your house. So it's taking that solar energy, which isn't readily usable unless you put it into a battery, and making it available to power your, everything you power in your house.
These units were going to be placed on the side of residential houses, usually under an eave situation, like a gabled roof or something like that, that would keep direct water from raining down on them. The top of the unit is actually open because there's an air vent that convective airflow comes up through to cool the unit, and it's assisted by a fan. The fan is made for outdoor use. And has all the protections that it would, but leaves could get in there and all kinds of things like that. So it was just keeping all that stuff in mind while doing the design and making sure that the water didn't get trapped anywhere, because that's the water that's going to cause you problems. And making sure that all the surfaces drained away from any electronics or anything like that were beneath them.
Yeah, originally it was to just engage spec to completely redesign the external skin and improve the look of it, but it migrated into a full mechanical engineering, thermal, weight reduction, cost reduction exercise that spanned over the course of about a year.
They had decided to use OEM inverters from different manufacturers. And part of our challenge was to get all of those different disparate inverters to look like one cohesive family. So our goal was to create a family sort of look, a corporate brand, starting with one inverter, which was the big one. It's about the size of a suitcase. It gets attached to the wall of a house, exterior wall. Anyway, so that was the challenge, was to develop a brand identity for their products and then migrate those into their other products down the road.
Overall, it was important to them to have a much more striking presence in the marketplace, something that was easier to hook onto the wall, something that was going to be lighter ultimately. And so our initial concepts really attracted them, and then our ability to drive the overall cost out of it was a big part of it, and then our ability to really manage the entire process and not just one part of it helped streamline it.
So we did 2 phases of industrial design. We started with some conceptual designs that we did in rendering form. And the reason why we did them in rendering form as opposed to making models is that we had to match very closely with their CAD geometry. So if we were to do foam models, some areas might be off and they might be a little not representative of what was real. And so we did renderings based on their CAD data. We did 4 different versions. Each one had a particular attribute that was different from the next, whether it was style or whether it was functional or whether it was some other feature. And went through that presentation with them. Shortly after, they picked the one design that ended up being the one that went to the show.
So if you think about the size that you need to power a whole house, it just gets bigger, right? Because it's converting more power. It's making that readily available. So, and a lot of it is just like heat dissipation as well. So it tends to get really hot, so it has to have a lot of like cooling features built in. And then these are outdoor rated, so it's sitting on the side of a building, so it has to be very rugged and can't let water in and all that stuff.
Side panels for the show model were actually held down with magnets. Really, really elegant solution. Everybody loves to use magnets because they're neat and all that stuff. But I know from experience that using magnets in a production atmosphere is typically cost prohibitive because each magnet is at least $1. And these guys are trying to shave off quarters of cents in some of their parts and things like that. So there's no way that was going to work. And also, magnets have a problem being in warm environments, like an inverter. Not just the environment that it lives in, but it creates quite a bit of heat during its operation. So what we wound up doing is having the side panels actually screw on, and that was an exercise in working with the manufacturer, because we were screwing to both the base that was their current product, and at the same time it was also screwing to our new part. Screwing to the new part's not a problem because we have control over that.
They have a range of applications, but the most common application for this one, which is a string, so it's kind of a mid-size. It's not like a micro. It's kind of the typical size you would use for one house, right? It's a single-family residential house.
One of the things that we always do in our design process is look beyond just the object itself, beyond just the product that we're designing, and really understand not just its users, but the environment and the context in which the product is used, or where it lives, or and we draw references from there. And so that's what we did in this case. The product has some sort of something in it, like a hook, like a visual hook, so that when somebody sees it, and maybe it's not readily noticeable, maybe it's something that you see after the third time you look at it, or maybe you see it after you get up close to the product. But it's something that's memorable, and it's also something that perhaps they can use in their brand identity, like as a background or as a theme in their marketing collateral or on their website. And so that was something that we'd had in the back of our minds. And we tried some things with color at first, and they didn't really care for those. It wasn't having the impact that they thought. And so I suggested bringing in this element of a patterning. And they said, oh, that's cool, let's see what that looks like. So I sat down in Photoshop and did some experiments where you take a gesture, you can even take a photograph, you can take a letter. What you do is you blur it out to the point, and then you create a very coarse halftone of that pattern, or of that image, and it gives you a really interesting look. And so we applied that graphic onto the model in Photoshop, so they could say, and they got really excited about it. They're like, wow, this is kind of the kick that it needs. It's kind of a really identifiable mark. It's subtle, but when you get up close, you can see it, and it's really, it has a tactile feel to it.
I think through it all, the thing we're proud of is we stuck with it. The end result product is really successful in the marketplace, and they like the design, and that the mechanical engineering piece is really high end and done. Despite the fact they had a reasonably good engineering team, they still chose to outsource the majority of it to us.
You want to take my seat and talk about advanced energy? You probably did a better job.
I like making fun of bad design, let's put it that way. I need somebody to do that with. Like the Pontiac Aztek. World's ugliest car.
There we go. Where did you find that?
I can't act in this case.
He said we-
Can you guys actually talk somewhere else? Sorry.